Welcome to the 3D Systems Rapidform 3D Scan-to-Print webinar. Today with the topic Make Your Own Phone Case. I'm Tobias Klein, Product Manager of Rapidform EMEA, and we will have today a webinar about the use of Rapidform for 3D printing content creation based on scan data. Why should the customer choose a Rapidform? Because we are part of 3D Systems. 3D Systems is the leader in ideation to production. We have experience in developing Rapidform software since 1998, with already more than 10,000 licenses sold worldwide. Our innovation is based on 40 Rapidform research and development people. We are inventor of modern scan-to-CAD methods and have more than 30 patents on Rapidform. Our support has 30 in-house engineers dedicated to Rapidform customers. It's a technical center, and more than 200 resellers certified to train and support Rapidform. Our strength as a total 3D Systems company, we are listed in the New York Stock Exchange with the ticker symbol BDD. And we are trusted already by thousands of customers as Rapidform. This is small selections of our very important customers. Now we want to talk about that mobile phone cover creation. So as a reference here would be Samsung or Sony or LG, something like that. But many more. Okay, so one thing about Rapidform is we are a software to create CAD models, manufacturable CAD models, which are actually parametric, from native scan data. So we can use any point or mesh creation device, whether it's a CMM or an optical scanner or laser scanner or any other device which can generate point clouds or meshes. And with this raw scan data we can create manufacturable models and send this model to a 3D printer. Again, we can use the STL format to be compatible with most of 3D printers. In this case, we also, as 3D Systems, provide a variety of 3D printers in different sizes and different materials and so on. So this part of the webinar is about the content creation from raw scan data. Rapidform is considered a reverse engineering software. However, if you want to create something from something existing, you may need to create something new, which is not already there, instead of just copying something. And therefore, it's also forward engineering. And the same method is used in CAD software together with 3D scanning, or only in the CAD software. So you create some content which you want to product. And if you use only the CAD software, you may need 12 hours for the engineering task. And if you use 3D scanning and the CAD software, you might need only 6 hours for the task. But if you use XOR, which is a complete solution for all this, you may need only 1 hour until you have a completely functional model which you can actually manufacture. Here are some examples of what I will show you next in the live demonstration. And basically this is the creation of some accessory for your mobile device or for your tablet. The positive aspect of this quick creation is you have a mass customization advantage. So if customer wants to have a different design or a different functionality, then you can easily change the model inside XOR by referring to the original product actually, and you have a completely new product to manufacture using 3D printing. This is another case, eyeglass cases, and yeah, here again you have one source scan data, and from that source scan data you can, in Rapidform XOR, you can design what you want, what you need, or what customer wants, which design alteration the customer needs. Okay, so I will show you a live demonstration. After the live demonstration, there will be enough time for questions, so if you have questions, you can put them in the question panel, and after the live demonstration we will have enough time to answer those questions. So basically this is what I did so far, and I want to show you how I got this model. Basically we start from scratch with a new sketch. Basically this is the scan of a mobile phone. It's a partial scan actually, and this scan is pre-aligned to the coordinate system. We have several functionalities to pre-align that scan to the coordinate system, but this scan is only point cloud or mesh, and it's incomplete. And with this situation of the model, you cannot print it directly, and you also don't want to print it directly. You want to have a cover which is clipped on this part. So this is actually our base to invent something new, and we will construct in this part. So I basically use this as reference for a construction. I have my front viewing plane, my base plane. On this base plane I create a so-called mesh sketch. This mesh sketch is basically capable of extracting a section or silhouette from that part. So here we have a section, or if I create a volume here, so this volume is basically a projection distance. So within that projection distance we can project every point in this scan data down to the sketching plane to have a silhouette. And on that silhouette we can automatically sketch our base outline for that model. So if you want to design a product, you normally use the top-down top-down method. So you define the product size, and I'm just doing this here quite quickly, defining the product size. So this 45.2 width and is about 98 height. And at the beginning there was the center line. So we have a center line here, and we can lock that center line to make it symmetric. We can lock that center line to the center, and then we can say, okay, this is from here 43.5 millimeter. So now everything is fully defined, and this is only our helper construction. So we don't need this as regular geometry, we need this as construction geometry to define the sizes of the part. So now we have a method to get this feature out of our 3D mesh, and this function is called AutoSketch. So that AutoSketch I can define sketch resolution, and this sketch resolution is calculating based on the curvature difference. So whenever I have another curvature, so this is one, this is another one, this is another one, and so on. So whenever I have another curvature, another segment is created, and I can create several segments on the fly, and those segments are already CAD segments, so I can define constraints to them. So let's say that is the middle point, or that is the tangent to that object, and then here we have the middle point as well, and this one is normal to that line, and this one is as well normal to that line. So now we have the symmetry, and now I can mirror this left side over using this symmetry, getting this one, this one, this one, and this one. And now I want to see what I did actually. So we have an accuracy analyzer. This accuracy analyzer is always available at any time of the modeling process. So you can, at all times, you can see how accurate you are modeling. In this case, we can just enter some dimensions. Let's say this is 8 mm. And of course we are symmetric, so this is the same. And I can say this and this is as well. Same radius, 8 mm. Close the profile. And mirror this one over again. So now everything is green, okay? So now we define the product outline, and with that product outline I could directly go into the creation of a solid using a middle plane, for example, and create a solid. I will cut away this upper part later, so I will extrude it a little bit more. So, and as you can see here, if we go into the 3D mode, we can also see this is our accuracy. So if you hover the model with the mouse, you can see we are inside the tolerance zone. Here is green area, and in the green area it means we are inside the tolerance zone. Red area means we need to do something to the model again. So this is basically the outline. And now we have, I already made another sketch which is extracted from the side. It's basically the center sketch, and I will use that center sketch and the other center sketch to create a surface. It's a revolving surface basically from this sketch, and using the other sketch's axis. So let's get this axis. Now we can define a middle plane, and we can say we want to have this rotated about a certain degree. And now let's have a look at it. So it looks pretty nice. In this area we want to have this surface. So it's basically our top surface for this object. So now we can use that solid body. We can use the cut function. We use that tool entity and that target body, and select the remaining body. And now we have our bottom part, which is actually a rough design of this phone case. But there are some missing features, so we will care about that features now. Basically, when you look at we have some transparency here. We can turn on transparency of the object. So when you look at the top, you can see that this top line, this character line, is a little bit offset from that top line here, and this is also a little bit offset. So you can use those features and offset them. And on the other side, if you look at this character line is flowing here down to that point, so we can also use an offset from here and connect it with a tangent line to here. So we get a really nice curved character line up down to here. I would design that character line in 2D as well, so I can use this front sketch again and just use a sketch looking from the top to that part. And let's see the first sketch which we did. That was our first sketch. So I can reuse entities which I already created. I don't need to create them again. So I can reuse the sketch and convert it, and I can get this line and convert them, and I can use them as construction geometry for the next sketch, then I can use an offset. So I can define, let's say, a 2 mm offset here, and I think in this case 2 mm will be quite okay. So I can say in this case we have an offset of, let's say, 4 mm. In this case 4 mm. Then I can make dimensions. Let's say in this case I will just use the numbers, or I can also use the center line again. Until here, and get symmetry and define that distance here. So we can say this is my 2 mm offset, and the same here. We can design from here to here also a 4 mm offset. Come on, 4 mm. Now it should work. 4 mm offset. Okay, so we have the 4 mm offset, and now we have our first sketch, and I want to connect that point to here. So I can also convert this point. And then I can create a tangent to here, to this point. Okay, so that is this curve or down here. So we will do the same thing on the other side. Here we can use a fillet and design the fillet so that it fits roughly. We will tweak that value later, so now I can say it's just 5 mm. We will tweak that value later when we see the whole model in 3D. Then we can check the deviation and we can tweak that numbers until everything is green. So in this case I just need to close the profile to have just one. That works. Okay, that works as well, and I can say I want to have a number here. Let's say 17.5 as the number. So now everything is defined as well, and I can use this line to split the face top. So I can split that face, and that face. So as you can see here, when we go to the accuracy analyzer, then this splitting line is exactly following this the difference between the green area and the red area. So we will make a chamfer around here. Basically it's a loft, but it would look like a chamfer. So in this case we need another line around here, and we can draw that line again reusing another line from which we drawn before. So we have this line already, so I can use this plane and create a sketch on that plane. And I can reuse this line, convert it, make it as a construction geometry, and I can create an offset of that line, and by just looking at that model we can see there is some light reflex here. In this case there is a fillet area, and on this fillet area the light is some highlight, and I move just the lines that highlights with pretty accurate actually. So now I can go from here and again draw a line to here and define that distance, offset distance. So let's say we have 2.75, or let's say we have 2.5, then we can tweak that later. So 2.5. Now again with that line I can split some faces. So this line is used to split this face. Okay. So, but we have another face here. So some green area around here. So if you have a look at the transparency, here is also some line straight through this face. So we need another face. We can define that from this sketch as well. So, and we have this corner. We can use that corner and project it to that sketch, and then use a horizontal line to split that face actually. So I will just use that face. Get a horizontal line here. And put that line to that point. Then we can create a smooth transition from here to here using tangent arc. So now we need to split that, and everything which we did before is parametric, so I can go back and just change the method. So here's the target entity which I need to split again, this one and this one. Okay, so it's split. And then the next step would be replacing those faces by loft surface which is running around here. So I can delete that face. Actually we are now modeling still a solid, but in XOR we don't separate between surface and solid, so every closed surface set is automatically a solid. And if I delete some surfaces from that surface set, we get an open solid, so it's a surface. Now I will go here and delete those surfaces. So delete those surfaces. No, I don't want to delete this one. I want this and this. Maybe I missed something here. Oh, I'm sorry. So I need to go back to that sketch, get the top view again. So I just make sure that this face is separated from this face, so now it works. Okay, again, delete that face, this one. So, and because we want to have a cover, we can also delete the bottom face as well. So I can just remove this face, then we just have the surface set. And with that surface set we can just close this ridge around here with the surface loft using profile, here, this profile, and I can connect the next segment to a connected profile, combined profile. So I can use this one, and use a guide curve around here. So it's pretty pretty cat-like, so very nice looking surface. And the next one is this one and this one. And here we have a segment, so we will get a segment here as well. However, this is a tangent segment, so it doesn't affect any surface continuity. Then a loft around here, a loft around here, and a loft around here. The next step is we don't want to make the lofts around here because we have the mirror function. I can use the mirroring. Just click those bodies and then use the mirror plane to mirror the features over to the other side. So we have now our complete design of that hull. So now we have still several surfaces, and I need to combine them using the su command. So I can just use su command on every surface to get that surfaces together to one complete surface set, which is actually in this case. So let's go ahead with the next step. So this is basically what we did to get the rough outer surface of this model, and we still have several blue and red areas, and we can still tweak something, so because this is not yet very accurate, so we can still tweak it. We can, for example, we can do some drafting around here, so we can insert a new line around here and then just fold a part of the surface to the inner side so that it drafts in one. I will use that drafting as well from the center plane. It's basically the same like we did before. Choose one sketch, let's say this one, and choose a sketch from here, flip it over, and now let's see, we need to convert this part and this part. We need to reuse that, use that as a construction geometry, and then find a point here because we want to change something here down. So now we need to offset this one, and we can see here is some ridge, and we can just move that line to that ridge somewhere, and I can define a line again from here as a center line, level line from here to here, and define the line length, so it's, let's say, 5 mm. And now let's see where this goes. So it's basically perpendicular to this one. And then we need a tangent line here from here. Go somewhere there. Maybe to this vertical line, and then define some radius. We can see here is some noise in the scan data, and this noise is the curvature of the flow is changing around that area. So I can assume that this is the change of the draft around here. So I can say this is my 25 mm maybe, or 22.5, something like that. We can tweak that later as well. So now we are splitting that face as well using this tool entity and selecting the target entities. So we have this one, 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 and okay, that's it. So now what we need to do now is we just need to draft those faces inward about a certain angle. And we have several drafts, so this kind of draft is the parting line draft. So we have a parting line here, and we need to define a pull direction. This is the mold opening direction, and you can say this is our parting line, and I want to have a draft into that direction. So basically, we just define those lines to be drafted in this direction. Okay, then we define the draft angle. Let's say it's 5 degrees maybe, and let's see the deviation analysis. So it looks quite okay. We have to consider that around that edge there will be a fillet area, so it's quite okay. We can cover the last bit with the fillet. So now we have the draft around here. Let's save the model again. Okay, next step would be to generate fillets around here and generate the flowing fillet around here. So we can do several fillets. We can do constant fillets, but we can, in this case, it's yeah, okay, let's do the constant fillet first. So let's do the fillet with, let's say, 5 mm around here, or let's say 8 mm. 8 mm around here. It's a bit big, let's say 7.5. So it should look quite nice. So 7.5 in this case as well, 7.5. So then let's get another fillet around here. That is the fillet around the draft area. Okay, so filleting is quite difficult in this case, so we can use a face fillet in this case to get the right fillet in this area. Let's get that fillet back. So we'll do that fillet first, this one. So you can see it's a face fillet. And now we have a feature which is called constant width. With constant width you can design nice fillets along character line. We get this character line with 1.5 mm maybe. Okay, then we can get the constant fillet maybe around this area, and then we can get the next face fillet around that area. Also with the constant fillet. So check the deviation again. It's quite okay, still a little bit different. In this case you could change that flow of that line a little bit, but we'll leave it at that at the moment. So from the top we have several features now which we want to cut out, because this is a cover. This should come over the scan data. It's not representing the scan data. We don't want to print it exactly like we scanned it. We want to create something new. So I will create a thickened pull which comes over this piece, and then we will cut out those features to be able to operate our phone. So in this case you can use the feature thicken, check that body, and in this case we can thicken outward by 1 millimeter. And we can see from the inner side now we have our phone case, and from the outer side we have something new. We have material on this part. Okay, now let's get a fillet around here with 2 millimeter or 1 millimeter. Okay, so basically this is our cover, and we can go on with more features now using that front plane as well, and using the sketch, looking at the front of our phone cover, and just getting, again in this case, offset from here, offsets from here, create a straight line, create a rectangle. In this case we can create two half ellipses or circles, whatever. So in this case we can just really design our holes in this model by just referring to our initial sketch. So convert this one, create a horizontal line, check here, this is construction geometry, then make an offset from this line, make an offset from this line, again we can create some dimensions or just fill it from here to here, from here to here. And then just mirror those features over, and then just combine those lines together so we have this area created. Or in this case we can just create an ellipse from that point somewhere to here, somewhere to here. To cut out that area. Just go through all and cut it out. So now this is going straight, but we want to have it a little bit sloped. This is also possible, so just by using a second sketch around here and cutting out the lower sketch on the lower surface and the upper sketch on the upper surface, and then combining using a loft similar like here. Yeah, basically this is how to create your own phone cover. I think you pretty much got the impression how to operate this tool to get the features out of your original part and to get a construction CAD model. But now how to do printing. So to go to printing we need a mesh again, we need STL again. To get that STL we just create an empty STL mesh. Just like if we got a scan and we have an STL mesh with some polygons in it, now we create an empty mesh. And in that empty mesh we can convert our solid body. Convert body command, and now we can click that solid body and we can define the quality, the tessellation quality, high, low, or we can even define advanced tessellation quality, chord height, or edge length, minimum, maximum. And so a mesh will be generated, and if we compare that mesh to our original mesh, then this one is completely printable. This mesh, you can see Again, this is mesh. Okay, so far the demonstration, and now we have question time. So one question was, how many scanners are supported? We support many import file formats. Here we have a file format input list. So it starts from some common file formats like STL, OBJ. We also have several native scanner file formats like NextEngine, Steinbichler, Breukmann, Vivid, and so on. So every big, like GOM, very big scanner file formats are in here, and we can load all these file formats. Okay, there is a question, how can we calculate the chord? The chord is basically calculated like in the mathematics. So you can directly enter the chord length or the chord height. So the chord is basically if you have a fillet area. If you have a fillet area around here, then you can see the radius is segmented into several lines of triangles like this, and this is based on the curvature. So the higher the curvature, the more triangles are generated normally, and the lower the curvature, the fewer triangles are generated. So you minimize the deviation from the original CAD model, and you can also define if you want to have a equally distributed chord length, then you can also define the chord length manually. Okay, any more questions? So the question is, what can we do with the CAD data? Sure, actually we can use the CAD data in every native CAD application as well. So we can use a live transfer to the major CAD applications like SolidWorks or Siemens NX or Creo, Pro Engineer, AutoCAD, Inventor, and CATIA. In case of SolidWorks, Siemens NX, Creo, Pro Engineer, we can live transfer. In case of Inventor as well, you can live transfer. That means if on the same computer those CAD software packages are installed, then we can directly transfer the history of the modeling tree to the CAD software package. So you can directly use what you prototyped before, you can directly use it for production. And for AutoCAD and CATIA, there is some exchange module, because CATIA uses a very different, CATIA and AutoCAD use a very different approach to importing those files. We have an export filter for AutoCAD and for CATIA. Okay, so there is a question about automatic surface creation from scan. Automatic surface creation is of course possible. So if you want to create a surface automatically, this surface is not a CAD surface. This surface is just an as-built surface, which is basically converting the mesh into a surface. For this purpose, the mesh must be smooth and closed. So you can do that by just going to the mesh and closing it. So I will just make a copy of that mesh and I can demonstrate it. So I will copy that mesh, insert it again, and to close it we can just double click that mesh and then close every hole just using fill hole with the right mouse button. So in this case fill hole, so we have a whole navigator here. So now we navigate to the next hole. There is something strange in the mesh, so some minor defects. So those minor defects can be cleaned by the healing wizard. So we have a healing wizard here. This healing wizard finds the most regular errors in the mesh and can remove them, clean them and remove them. So the healing wizard is actually searching for several errors like folded polyfaces, dangling polyfaces, 2 or 3 sides open, or small clusters, small polyfaces, crossing polyfaces, small tunnels. And it can happen that not all errors can be cleaned, because if I clean away one error, one other error is next to this one and is now obvious, and so the remaining errors can be found here and can be just deleted with the delete key. So now we have the errors deleted. So now we can fill the remaining boundaries, all except the biggest one. And check again whether there are some problems, but there are no more problems in the mesh. And then I can get the curve of the outline to make it smooth. I can use edit boundaries command and get the curve smooth, or fit it to a freeform curve. Just fit that one to a freeform curve and then define local smoothness. Just like this. And there are several smaller pieces which needs to be fixed as well, so you can go back to the hole filling algorithm and then just maybe delete this one and just fill from there to there. So we have several methods to clean the mesh completely. Now, if the mesh is cleaned completely, we can use a very easy one-button solution to convert it to a surface. This is called auto-surfacing. Auto-surfacing has 2 different methods. It has the evenly distributed network and the feature following network. So evenly distributed network is basically creating curves like squares or rectangles on the shape, and the feature following network is basically trying to follow the features. So not always possible, but it's possible most of the time, and it's generating quite nice surface following around curvature. So this auto-surfacing takes some time to calculate, of course, because it's a non-interactive, mostly non-interactive layout preview. You can tweak a little bit this layout, but it's mostly automatic, and therefore it needs to calculate the curvature of the whole mesh, it needs to calculate the character lines and everything, and then it calculates the complete curvature network. So this is basically the curvature network, and as you can see here, it's already following the features very well. It's not like CAD, but it's pretty much it's for organic shapes and such. And in this case, sometimes an error happens, so you can correct that error just by moving some things, moving some line, and the error goes away. So this is basically auto-surfacing, and this is a as-built representation of the scan. So hiding the scan, showing the surface, and that shows some isolines. So this is basically the surface. Of course, with this surface, you could also, if you have a complete closed scan, you could also go into the CAD program, but you cannot modify the surface anymore. This surface can be as well exported to STL, but why are we going this way around that surface? We can use the scan directly. If we close the scan already, then we don't need this surfacing, and we can use the scan directly and export this to STL. It's also a mesh which can be exported to STL. However, it has no thickness, so it cannot be printed directly. If we want to have a thickness, then we can use a thickness, but we are a surface or CAD modeler, not a mesh modeler. So thickness to a mesh is all we can do to the mesh itself to make it a volume. So if you want to model something, if you want to create something new, you have to go to create a solid or surface, something like that. Then you can basically design your own character lines and everything. Okay, so still 5 minutes left. Still any questions there? If you have more questions which cannot be answered in a short time, you can feel free to send an email to eusupport@rapidform.com, and we will be happy to answer your questions. So even though you cannot ask the question here, or the question is too complex, you need some maybe sample modeling or something like that, you can write to eusupport@rapidform.com for the technical stuff, and you can write to eusales@rapidform.com to regarding some pricing information or sales questions. Okay, that was the webinar. Thank you for your time, and I hope you enjoyed it. I hope you saw how we use Rapidform to model our own design from an existing object, from scan data.